Hello everyone. In this video we will see problem related to the parabola in complex plane. See, you are having the question like that. If z satisfy modulus of z minus 1 that is equal to real part of z, then what is the locus of z? What is locus of z? See the question. If z satisfy modulus of z minus 1 equal to real part of z. This is modulus of z minus 1 equal to real part of z. Then what is the locus of z? So this is, we have to solve by putting x equal to z equal to x plus iota y. X plus iota y. So this become x minus 1 plus iota y ka modulus, and that is equal to real part of x. Z is x. So therefore we are having square root of x minus 1 ka square plus ka y square equal to x. Finally you will get the equation. From here you will get x minus 1 ka square plus ka y square, that is equal to x square. So x square will get cancelled out. So therefore this is minus ka 2x plus ka 1 plus ka y square, that is equal to 0. Finally we are having y square equal to 2ax minus 1. Now y square equal to 2x minus 1 can be written as y square equal to 2 into x minus half. Now look at here. Clearly this is the equation of parabola. Okay. So the locus of z is parabola. Okay. Now further they can ask what is the vertex of the parabola. So the vertex is 1 by 2 comma 0. What is the value of a here? See, 4 of a equal to 2. Therefore a equal to 1 by 2. What is the coordinate of focus? So focus is a distance from vertex. It is vertex. Then the distance between vertex and focus is a. A is what? Half. Vertex is what? 1 by 2 comma 0. So therefore focus will be half comma 0. So therefore focus अपना 1 comma 0. That is focus. Focus is 1 comma 0. Correct? So in that way you can solve the questions which are based on parabola in complex plane. In fact, if you see this form, that is modulus of z minus 1 equal to real part of z, that is going to represent definitely a parabola. Then convert it into the coordinate geometry, find out vertices, focus, value of a, and all those things now you can do. Now coming to the second question. That second question is very important. What is that? Second question is like that. See, this is z satisfying modulus of z minus 1 equal to real part of z, then minimum of z minus 4 minimum is equal to how much? We have to find out the distance of z minus 4, the minimum distance, and z is lying between, z is lying on this parabola. We know that. Now we know that this locus is a parabola. Okay. Here z minus 1 is not. In this question we will take z minus 2. In this question we will take z minus 2. Okay. Earlier z minus 1, it is z minus 2. So therefore we will have the modulus of x minus 2 plus ka iota y, that is equal to x. Putting z is equal to x plus iota y. So this gives x minus 2 ka square plus ka y square, that is equal to x square. Correct? So this is minus 4x plus 4 plus ka y square equal to 0. Finally we are having 4x minus 4, 4x minus 1. Now y square equal to 4 into x minus 1, clearly a parabola. So this is very clear that this represent a parabola. Correct? So the locus of z is a parabola. Z lies in parabola with vertex. Vertex at 1 comma 0. Okay. 1 comma 0. Now the question is you have to find out the minimum value. Means if we are having like that. See, if I am having, okay, this is say 1 comma 0. So your parabola is like that. Correct? Right opening parabola. And 4 comma 0 is here. You have to find out the minimum distance. Z can be lying over here, here, anywhere. Suppose Z is lying over here. So you have to find out this minimum distance. Okay, now question is over. We understand what actually we have to find out. Now the question is how to find out this minimum distance. We can find out this minimum distance two ways. Okay, we know that the shortest distance, the minimum distance always occur along the normal of the curve. So therefore normal equation we have to determine. But mind it, this is not a standard parabola y square equal to 4ax. Rather it is a y square equal to 4 of x minus 1. So therefore and that 80 square 280 parametric coordinate will not be there. That am square minus 2am will not be the feet of normal there. You cannot write down the equation of normal like y is equal to minus tx plus 2at plus at cube like that, because this is something a shifted parabola. So first first we are using that method 1. So I am using the same concept, that is the equation of normal. Equation of normal is y is equal to minus tx plus 280 plus ka 80 cube. If it is a y square equal to 4ax standard parabola, but this is not a standard parabola. So therefore here equation of normal is y is equal to minus t, and x is here x minus 1. And rest is 280 plus 80 cube. Now putting the value of a, 4a equal to 1. This gives a equal to 1. So therefore the normal is y is equal to minus t x minus 1 plus ka 2t plus ka t cube. This is your normal. Correct? Fine. And this normal is passing through the 4 comma 0. So 0 equal to 4 minus 1 minus 3t plus 2t plus ka t cube. So 0 equal to t cube minus t square minus 1. Finally we are having t equal to 0 plus minus 1. Now t is equal to plus minus 1, t is equal to 0, but what is t? T is a parameter where we can find out the coordinates of any point which is lying on this parabola. Now the parametric coordinate, from here parametric coordinate will be not like that 80 square 280, not like that. This is not y square equal to 4ax ka parabola. So therefore here see what is that here. 4 is a perfect square, this is a perfect square, right hand side has to be perfect square. So x can be t square plus 1 only. Plus 1 minus 1 will get cancelled out, then we will have 4t square. So therefore x can be t square plus 1 and this is 2t. That is your parametric coordinate. That is any point, that is z, can be represented by t square plus 1 comma 2t. Clear? Okay, fine. Now you can find out the coordinates. So therefore we can have 3 coordinates, that is one is t is 0. So 1 comma 0 to 1 comma 0 is already there. Na? This is 1 comma 0 and this distance is 3. So that is the distance is 3. Or we can have, if t is plus 1 then it is 2 comma 2, and if t is minus 1 then it is again 2 comma minus 2. So we have to find out the distance of 2 comma 2 with 4 comma 0. So this is square root of 4 minus 2, 4, 0 minus 2, that is again 4, that is 2 root 2. Definitely 2 root 2 is minimum, then 3, less than 3 na? Okay. And here also, same, here also, 4 comma 0. So therefore distance is square root of 4 minus 2, 2 again 4, 0 plus 2 again 4, that is equal to 2 root 2. So therefore finally you can say that the minimum distance is 2 root 2. This value is 2 root 2. In that way you can solve this. Now I have applied here the concept of normal, but I can also apply the concept of application of derivative. Maxima and minima concept we can apply. Method 2. So method 2 I am doing. Okay, we are having this parabola y square equal to 4 into x minus 1. So your parabola is method 2. Y square equal to 4 into x minus 1. So this is your parabola. Okay, this is 1 comma 0. This is your 4 comma 0. And your z is lying over here. Let the z is x comma y. Okay, we have to find out this distance. What is this d? D is square root of x minus 4 chi square plus chi y square. Therefore I can have d square. Maxima minima concept we are having. So d square equal to x minus 4 chi square plus chi y square. Let this function is fx. Okay, x minus 4. Actually what happens, we have to convert this function in only one variable x. So y square I can put from here. So this is d square equal to x minus 4 chi square 4 into x minus 1. So this is your function fx equal to x minus 4 chi square plus 4 into x minus 1. Isn't it? This function has to be minimized. Correct? This function has to be minimized. So we can find out f dash x. F dash x will be 2 into x minus 4 and plus ka 4. That is simply 2x minus ka 4. Correct? Okay. 2x minus 4. Now f dash x equal to 0 gives x equal to 2. And f double dash x is 2, that is greater than 4. Therefore it is point of minima. That is minimum distance we can find out. When x equal to 2, we can find out the minimum value of y. So when x equal to 2, y square equal to 4, that is y is equal to plus minus 2. Correct? So here we can take it as 2. The point is 2 comma 2, which is at a minimum distance from 4 comma 0, and therefore minimum distance z minus 4 minimum is 2 root 2. This concept we have applied. This is from the application of derivative. Correct?